Hey guys, hope you guys are doing well. We're going to talk about limiting reactants today. Just reviewing vocab real quick, a reactant is going to be something that you start with in an equation. So this is going to be like whatever you add to the mix or whatever reaction you're trying to complete. So your objective for today is that you're going to be able to tell me which reactant is limiting. So limiting, it sounds just like what it is. This is going to be something that prohibits us or doesn't allow us to get as much as we want out of the equation. So an example would be you're making hot dogs and they never come in the right amount that you need, right? So you buy a pack of hot dogs and they have 1, 2, 3, 4, 5. They come with 5 hot dogs, and then you buy the set of buns and the bun only comes with 4. So these are going to be like your reactants, your hot dogs and your buns. And we figured out that the limiting reagent is going to be the buns because you're going to end up with a leftover hot dog. So we're going to have a little bit of an excess of hot dogs. Excess is like extra. So theoretically, we should be able to make 4 complete hot dogs in a bun, but we'll have an excess because the buns are limiting and we have enough hot dogs to make 1 more, but that's going to stay as an excess since we don't have enough buns. So again, we're going to relate this to chemistry. So in order to identify the limiting and excess reactant, you have to start off with some kind of grams, like weighing your reactants, how much are you mixing in the first place. And that's going to allow you to determine whether the H2 is going to limit us or the O2 is going to limit us in order to make H2O. So you're going to use a gram to mole conversion for this. So again, if you don't have your foldable made, go ahead and write down that for limiting and excess reactants, you're going to use a gram to mole conversion. So you should pause now, tide out your paper, limiting and excess reactants, and write down the formula you're going to need to solve these problems. So this question is asking to identifying the limiting and excess reactant of H2 or O2 in this equation. So what you would do is have your formula off to the side. I'm already telling you, you're not going to have to decide which formula to use. It's going to be the gram to mole formula. So what you're going to do is you're going to pick one to start with. Pick one reactant to start with. So I'm just going to start with H2 since it's in the beginning, it's first. And then once you decide that, remember reactants are going to be what you put in. So they're always on the left of the equation. So we're going to start with hydrogen. You're going to start with your given and you're going to put that there. So you started with 8 grams and I just took this from whatever they gave me and I'm copying it down. So then you're going to have 1 mole given over grams given. And the grams given, don't forget, we have to practice this off to the side. So you would count how many H's you have, multiply by the molar mass, which would be 1. So you get about 2.02 grams. Then we can move on to our ratio, our mole over mole. So that's going to be from our formula, our coefficients. So we want to find H2O, like this is what we want to make. But given this much H2, how many moles of H2O can we make? So we're using the coefficients. And you don't use O2 because O2 is another given. These are both givens. And what we want in this case is going to be our product. So once you're done with all of that, you're going to multiply across, divide on the bottom, and you'll end up with 3.97 moles of H2O. And then you have to do the whole thing over again for O2 because we want to determine whether it's H2 that's going to limit us or it's O2 that's going to limit us. So you're going to write down your given, which was 8 grams of oxygen. You're going to multiply it by your mole 1 mole given over 1 mole, over grams given. Again, remember, please, 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 if you have grams, it's molar mass. That's going to require you to, off to the side, count your atoms of oxygen multiplied by the mass that you find in the periodic table. And that's where this 32 came from. And then the mole over mole is going to come from our equation. And in this formula, we started with O2, that was our given, and we want H2O. This is our wanted. So that's where we're going to get our coefficients from. 2 moles of H2O over 1 mole of O2, and these are from the coefficients. There's nothing in front of O, so we imagine there's a 1 there. There's a 2 in front of H2O, so that's where this 2 came from. Then you multiply, you're going to do 8 times 1 times 2, and then go back and divide by 32 and by 1. So you end up with 0.5 moles of H2O. So now that we have the answers, ask yourself, which makes less H2O? Which one is going to yield less H2O? It's very simple. Which one is going to be smaller? So, because this number is smaller, that means this is your limiting reactant. So oxygen is limiting us from making more H2O. Which makes more H2O? We have this big number here, so we know that this one is going to be excess. It's going to be more than we need. And that's pretty much the lesson. So I'm going to go now to your assignment. Classroom. Your assignment for today is going to be the same kind of thing that we did on Monday, where you have 4 problems. I gave you the answers already. All you have to do is show me the work. How would you figure this out? Again, today's a little bit different because we have our live lessons. So I am available for 2 hours today. So we can literally knock all these problems out together. I can walk you through the steps. I can guide you. Please come see me. Please reach out if you need help. If you just follow the formulas, you should be fine, but I'm available for anything you guys need. Good luck today and have a good Wednesday.